Hello again, Math 1 students. This is section 12.7. Using congruent triangles, we are going to learn something called Cpctc. So we're going to use congruent triangles to solve problems and to write proofs. So here is the acronym for the day. It's Cpctc. Now notice for all the proofs we've done so far, we've shown that two triangles are congruent, and those have always been the final statements. And the reason why they're congruent is something like SAS or SSS or HL or ASA or AAS. Cpctc is one additional step beyond that. So the second to last statement will be the congruent triangles, and now we have a last step. After you prove that two triangles are congruent, you may now show that any corresponding parts of two triangles that are congruent are also congruent using this abbreviation Cpctc. So in other words, let's say you have three sides that are congruent. Once you conclude that the two triangles are congruent by SSS, now you can conclude that each pair of corresponding angles are congruent, because that's the whole point of congruent triangles. So it basically links the three parts that are not used to form the proof as also congruent. So let's take a look at this example. Which triangles are congruent and how? So we're given that KL and LN are congruent, KM and MN are congruent. We can also state that LM is congruent to itself by reflexive property. So triangles KLM and NLM are congruent by SSS. So now that the two triangles are congruent, the whole point of Cpctc is that corresponding parts of congruent triangles are also congruent. So these triangles are congruent. Now we have the three angles that we did not use to prove the triangles are congruent. Those parts are also congruent, which means by Cpctc, angles K and N are congruent, angles KLM and NLM are congruent, and KML and NML are also congruent. So Cpctc, once you have congruent triangles, you can now state the remaining corresponding parts of those triangles are also congruent once you establish that the two triangles are congruent through a proof. So here's another example. Which triangles are congruent and how? We used this example in the last class. RS is congruent to UV, angle S is congruent to angle U. We know that by vertical angles, STR and UTV are congruent. So we have two congruent triangles by AAS. Now that means the other three corresponding parts are also congruent, the one remaining angle and the two remaining sides. So by Cpctc, angle R also has to be congruent to angle V. We know that RT has to also be congruent to VT because those two triangles are congruent and those are corresponding sides. Finally, ST is also congruent to UT. So let's take a look at these examples. Example 1a, given angle Q and angle S are congruent and that angles RTQ and RTS are congruent, prove that segment QT and ST are congruent. So the plan is this. You are going to be given two pairs of congruent angles. We're going to find that the third part of the triangle, which is RT congruent to itself, is true by the reflexive property. So we can conclude that the triangles are congruent by AAS. Now that the triangles are congruent, we can now conclude that QT is congruent to ST because that is one of the other parts of the triangle that are corresponding, but those weren't used in the proofs. Once you have two congruent triangles, you can now conclude that all corresponding parts are congruent, including this side. So you see what this proof looks like. You first prove the triangles are congruent, and then the last statement is what else you can conclude based on the fact that the triangles have been proven congruent. So let's take a look at the statements and reasons. Number one, angle Q is congruent to angle S, and that is given. Statement 2, angle RTQ is congruent to angle RTS, and that is also given. Statement 3, RT is congruent to itself by the reflexive property of congruence. Now notice I don't write the A and the S's in the margin anymore. You can write them in yourself if you want. So you have two pairs of congruent angles and a pair of congruent sides. So triangle RTQ is congruent to triangle RTS. And notice that the letters have to match up. This is by AAS. Now that you've proven the true triangles are congruent, the remaining corresponding parts are also congruent. So QT is congruent to ST by what we call Cpctc. Corresponding parts of congruent triangles are congruent. So you basically prove the triangles are congruent, and then the final step is using Cpctc to show that one of the remaining parts that are corresponding are also congruent. B, given AB is congruent to BC and AD is congruent to DC, prove that angles A and C are congruent. So here's our plan. We are given two pairs of congruent sides. We can also see that BD is a shared side. It is congruent to itself by reflexive, so we have congruent triangles by SSS, which means corresponding parts are congruent, so angles A and angles C have to also be congruent. So here we go. Statement 1, AB is congruent to BC. That's given. 2, AD is congruent to DC. And that is also given. Statement 3, BD is congruent to itself by the reflexive property of congruence. So now we have two sides given, and the third side we can use reflexive. So statement 4, triangle ABD is congruent to triangle CBD. And again, make sure that the letters are in the matching order. And this is by SSS. So now that the two triangles are congruent, we can now branch out to say the remaining three parts that are corresponding are also congruent. So statement 5, angle A is congruent to angle C by Cpctc. All right, 2a, given that angles 1 and 2 are congruent and 3 and 4 are congruent, prove that triangle BCE is congruent to triangle DCE. So notice this is not going to be a Cpctc problem. First, we're going to show that the two triangles are congruent, CDA and CBA. The top and the bottom triangles are congruent. Now we're given two pairs of congruent angles. And then we can also say that CA is congruent to itself by reflexive. So therefore, the two triangles are congruent. Now this is going to take another step. Now that you have triangles that are congruent, we can also conclude that CD and CB are congruent by Cpctc. So if you can follow along here, those two are now congruent. And we're given angles 1 and 2 are congruent. So now we have CE congruent to itself by reflexive. So basically what we're trying to do is prove these two triangles on the left side congruent. So by SAS, BCE is congruent to DCE. So notice what happens first. You first prove that one pair of triangles are congruent. You use the corresponding parts as one of the three parts to make a second triangle congruent. And that's how you do this problem. So let's take a look at the proof. 1, angles 1 and 2 and angles 3 and 4 are given. Statement 2, CA is congruent to itself by the reflexive property of congruence. So notice what we're doing here is we are first establishing that the top and bottom triangles are congruent. Okay. Statement 3, triangle CDA is congruent to triangle CBA, the top and bottom triangles, and that is by angle side angle. Statement 4, CD is congruent to CB. So notice with the top triangle and the bottom triangle is congruent, corresponding parts are also congruent. So CD is congruent to CB by Cpctc. So now we have one pair of sides. We have, well, we'll get to that now. CE is congruent to itself because the reflexive property of congruence. So now we have angles 1 and 2 congruent, and we have two pairs of congruent sides with the angle in between. So statement 6, triangles BCE and DCE are congruent by SAS. So given angles KFG and HGF are right angles, K and H are congruent angles, and we're going to prove that angles 1 and 2 are congruent. So here's our plan. The first thing we're going to try to do is prove KFG, that triangle, and triangle HGF are congruent. Now you will notice that we already have two pairs of congruent angles. We have angles H and K congruent as given. We also have angles KFG and FGH are both right angles, so they're congruent. Finally, we can show that FG is congruent to itself by the reflexive property. That is a shared side between the two triangles. So therefore, triangles KFG and HGF are congruent by angle, angle, side. The acute angle followed by the right angle followed by the side that's not included. So then we're going to conclude that angles FGK and GFH are congruent by Cpctc. So FGK and GFH are both the acute angles as part of the triangles. So now angles 1 and angles 2 are congruent by what's called the congruent complements theorem. If you remember that, that says that two angles that are complementary to congruent angles have to be congruent to each other. For example, if the two angles were both, say, 30 degrees, angles 1 and 2 have to both be 60 degrees because they're both complementary to congruent angles. So now let's do this proof. Statement 1, angles KFG and HGF are right angles. That is given. 2, angle KFG is thus congruent to angle HGF. And that is the right angles theorem, that all right angles are congruent to each other. Statement 3, angle K is given to be congruent to angle H. 4, FG is congruent to FG. This is the reflexive property of congruence. So triangles KFG and HGF are therefore congruent by AAS. So now what we're going to do is use Cpctc to link another pair of corresponding parts congruent. So 6, angle FGK and HFG are congruent by Cpctc. Means angles 1 and 2 are congruent by the congruence complements theorem. Again, the rule that if two angles are congruent to a pair of congruent angles, then those two angles, complementary to a pair of congruent angles, then those two angles have to also be congruent to each other. So that's it for section 12.7.